Hello and welcome. In this video, I'm going to complete a series of tasks for MPLS on OcNOS devices. The task is as follows. Provide IPv6 connectivity between ABC branches using 6PE technology. So there are two keywords here that are important. One of them is going to be the IPv6 connectivity and one of them 6PE technology. So these two are the keywords that we are going to focus on. And in this video, I'm going to do the configuration for you. But before that, let's take a look at the topology and what we have for now, what we are going to do in this video. Okay, so if you have watched my previous video, then you would know that I have configured 6VP in there, and there are some differences between these two technologies. If you have not watched, that's okay. I'm going to just explain that the network that we have here consists of different parts. You could say that, okay, all this network is part of the same enterprise, and this is an IPv6 island, this is another IPv6 island, and what I need to do is to just provide kind of a tunneling through IPv4 network. So this is going to be the overall configuration that we are going to have. Or I might say, okay, this is a pure IPv4 service provider, and it has some different customers. One of the customers is ABC, which needs IPv6, maybe because this customer has, let's say, some requirements. For example, there is an application here which needs IPv6 connectivity, and as a service provider, we need to provide it for them. Now, just assume that in this service provider, there are lots of P routers, but in my case, I have only utilized one of them. So there's no difference, of course, in the outcome. What is important is the PEs are not going to have any kind of configuration other than what they have already have. I mean, the provider routers are not going to change at all. What we are going to do is to do everything on PEs. And you know that PEs are going to be the intelligent part of the service provider. So this PE and this PE are going to have some changes. The changes should be minimal, and what we need to do is to first of all say that this interface and this interface need to have an IPv6 address. Also, we need, so that is going to be the interface address. So that is one of the changes that we are going to make here. The other thing is we need to create a new BGP address family. As a matter of fact, two BGP address family, and one of them is going to be IPv6 unicast, and we are not using any VRF in this case. So if there is a VRF, I'm going to remove it. One of them is going to be IPv6 unicast, and the other one, of course, is going to be what was that? The other one is label switching. IPv6 label switching. Labeled unicast, as a matter of fact, which is going to be for BGP. And BGP is going to create some labels for us. For each prefix that it's going to receive from ABC, BGP is going to create a label for us, and we can just see it inside MPLS forwarding table. And the other thing that we need to say here is the type of MPLS labels that we are going to use in here is going to be 6PE, because for every prefix that we are going to receive, we are going to create a label. Then we are going to call this per prefix. So that is what we are going to have. So by default, that is per VRF, but here we are going to do this per prefix. So that is going to be the overall configuration here. What we need to do is, let's say, I would like to create kind of an, what is that? Address family between router 2 and router 3. So router 2 and router 3 are going to have this new type of capabilities which we are going to add to our network. Okay, so that's an overall that's an overview of the configuration, what we have for now. Let's just take a look at what we have in this environment. So like I said, router 4 is going to be our P routers or provider routers. So if I just go to router 4 and just try to connect to here, I just want to show you the running configuration here. Just type in show run. It says that what we have here is just LDP, and I have a transport IPv4 address configured for that, which is going to be my loopback interface, and then nothing other than configuration for the interfaces and these two, which is label switching. And because I'm using LDP, that's going to have enable LDP IPv4 command under that. And the other thing, of course, is going to be the routing protocol for internal network. I have router 2 and router 3 as my PEs here. As you can see, I have reachability throughout my network. And if I just check the running configuration, I just want to show you what we have here. Previously, I had ABC as a VRF configuration, so this is what we had for that. We are not going to use this anymore in this new technology, 6PE, so rather LDP is going to be here. And then if I just go down, you can see that these internal interfaces have configuration for label switching, and this external interface which faces to ABC has this VRF configuration, which I'm going to remove it in a second. And then of course we have this BGP, and under BGP, because we used to we configured 6 VPE, you can see that VPNV6 is there. I'm not going to use this anymore, and I'm going to I'm not going to use this one anymore. So let's just do this configuration. So first of all, let's go to router BGP 100. And the thing that I'm going to say is I'm not going to remove this for now. Let it be there. Maybe there are some other customers that are going to be part of the VRF, but this one, I'm not going to have it anymore. So I'm going to say no address family IPv6 VRF ABC. But I'm going to have address family IPv6 unicast and unicast as a matter of fact. And under that, I'm going to say my neighbor, which is 2001.10.151, and that would be 1. I'm going to say it is in remote AS 100. And the first thing is I need to do this in global BGP configuration. And then under this address family, what I need to do is to activate this. Okay, so this is done. And I might want to redistribute the connected networks as well. So let's just do this. Nothing is going to be damaged. So I'm just going to commit this one. And now the thing is, the interface that faces here is under a VRF. I need to remove that VRF. So if I just go to here, that is the interface configuration that I have. I want to say no IP VRF forwarding. So let's just paste the configuration here because we are going to need it later. So I'm going to go to this interface and I'm going to remove this. So just paste it and then say no IP VRF forwarding ABC, and then commit. This is going to remove IP addressing and IPv6 addressing. I'm just going to apply them again. So I'm just going to copy this one and paste it here. What happened? Okay. Paste it here and commit this. Now, because now we have a direct connectivity, we do not really need to have a VRF inside our ping. So I can just say ping this 1 on the other side, and we have reachability. So if I just go to router 1 and check this, you would see that now we have IPv6 BGP summary, which means that we have the connection with this. We have the neighborship with router 2. Okay, the same thing should be done on router 3, which is the other one. And let's just go to here and say show run router BGP. and this is my BGP configuration for now. I need to go to router BGP 100. I need to remove this one. I don't really need it. And what I need is to enable this in global BGP. And then I'm going to say address family IPv6 unicast. Then I need to activate this. And also, let's say that I'm going to redistribute the connected networks. Okay, so this part is done. Also, I need to go for run interface. What is the interface here? It is on VLAN 154. So that would be xe4.154. Okay, so I need to remove this. So let's say that this interface, and I need to say no IPVRF, and I'm going to commit this. And then because I have lost my IP addressing, so I'm going to add these addresses and I'm going to commit them again. Okay, so this part means that router 6 now should have BGP neighborship again. So if I say show IPv6 BGP summary, you can see that it is in active mode, and after some time you should see that this is established. So I need to wait for this to happen. That's going to take some time, of course, unless my BGP configuration has been destroyed. So I'm just waiting for this. Let's go back to router 3 and just say show run router BGP, just to make sure that we have our neighbor. So that is here in 651 under IPv6 unicast. We have activated this. Okay, so everything should be fine unless I have no reachability. So let's just try to see if I can reach to here, which I can. So okay, it is now established. Now that we have established a neighborship, let's go back to router 3 and router 1. These two now need to have an extra command. So what I need to do is to say configure terminal. This command is MPLS label mode. If I just say MPLS label mode, you can see that there are different modes, and this one 6P is specifically what we are going to use, and it says the default is per VRF, but we are now changing this to per prefix. So I'm going to commit this one, and per prefix it says that in commit. Okay, so this should be done on router 3, which is the other one as well. And now that we have done this, we are almost done. The only thing that I need to just make sure is I have LDP and LDP neighborship is there. You can create a remote LDP session between router 2 and router 3 using targeted peer, but I'm not going to do that. I guess if I just say show run router LDP, this is going to be enough. Now if I just do some verifications, let's see. Show MPLS LDP neighbor. Okay, I have the adjacency with router 4. And if I just do this on router 4, it says that I have it with router 2 and router 3. Okay, so all the configuration is done except one thing, and that one piece of configuration is the key to establish everything here, and that is the new address family, as I told you. And for that I would say router BGP 100, and I'm going to say address family IPv6, and after that you can see that we have this labeled unicast address family. So what is my neighbor? That is going to be 3333. I'm going to activate it here and commit and end the configuration. So here there is a problem. What does it say? It says that, let me check. It says that I did it on the wrong router. This is router 1. I should do it on router 2 and router 3. Okay, so you see, abort transaction is always there just to fix your problems. My P's are router 2 and router 3, so I should do it here, not there. So router BGP 100, and I'm going to say address family IPv6 labeled unicast, and my neighbor is going to be 3333. I'm going to activate it and commit it, and commit. Why am I typing this like that? Okay, and on router 3, of course, the same thing should be done. Configure terminal, router BGP 100, and then address family IPv6 labeled unicast, and my neighbor, of course, is 2222, which I should activate it and commit it. Okay, so I'm completely done. All the configuration is done, and we are going to take a look at configuration again, but let's go for some verifications first and see what we have in here. The first thing that I'm going to say is, do I have the neighborship for this labeled unicast address family or not? So I'm going to say show BGP, and after I show BGP IPv6, as a matter of fact, you can see that there are lots of things that we can check, and labeled unicast is one of them. So I say labeled unicast and then summary, of course. Summary, and you can see that, okay, we have established the neighborship, and there are prefixes that are coming and going. The other thing that I want to say is show IPBGP neighbor, which is 3333, and I'm going to hit enter. The most important part is here. We already have had VPN v4 and VPN v6 capability, but now we have labeled unicast capability as well, and now we can just use that. Now the next piece of configuration, not configuration, verification, of course, is gonna be, let's say, I don't know, maybe show IPv6 route, and this means that we have received routes through BGP from others, and of course we can say show BGP IPv6, show BGP IPv6. It shows all the prefixes that we have received from different places. And one important thing is going to be show MPLS forwarding table, as I promised to show you that there are some prefixes here, and they have received the BGP label, as you can see here. Okay, so this part is done. What about the customer? Does the customer know anything about the other side or not? My customer is on router 1 and router 6. So if I just go to customers and say show BGP IPv6 and hit enter, you can see that I have received the route from the other side, which is my router 6, for example. And if I just say show IPv6 route, you can see that I have installed it in my routing table. So the last verification, of course, is going to be to check the connectivity. So if I just say ping IPv6 this, and I'm going to source it from this, you can see that the ping goes through without any problem. Okay, so let's recap. What did we do? Here on customer, we have nothing special, just an IPv6 unicast address family here, which is going to create a neighborship with the service provider. That's all. But on service provider, on PEs, everything happened. So if I just say show run and go down, we don't need VRF anymore. the interface is not going to be under any VRF. LDP is going to be here. You can create a targeted peer, or you can just go with normal LDP. That's okay. So you can see that this is the interface connecting to the customer. No specific thing. But inside my network, I have MPLS and I have LDP. And of course, you can go with some other technologies, for example, RSVP. That's okay. But LDP is something simple to configure. And under BGP, my neighbor is no longer under VRF. It is under IPv6 unicast. But between PEs, we have this new adjacency, this new address family, which is labeled unicast. So that's almost everything that you need to know about this kind of a configuration for 6PE. I hope this has been informative for you, and see you in next videos.